Okay, so good day, I'm Jefferson Garo, and today we are going to create or make another summary video on our NetAcad, okay, on our chapter 5. Okay, so I have here a summary that I've searched on SlideShare. So let's set up our screen recorder first. Sorry, I forgot. Alright, by the way, I have cut my hair today. I have my haircut for only 60 pesos. Share ko lang. So here, I'm using the A Power Soft screen recorder. Wait lang. Yeah. Okay. Let's move our camera here. Yes. Yeah. Screen. So let's record. Alright. 2, 1, bam. Okay, so here I'm using the slides on the slide share. Okay, so I'm just gonna read this. Okay, objectives. So upon completion of this chapter, okay, uh, I have able, or you will be able to describe the operation of Ethernet sublayers, identify the major fields of the Ethernet frame, describe the purpose and characteristics of the Ethernet MAC address, describe the purpose of ARP, explain how ARP requests impact network performance, configure fixed configuration, configure a layer 3 switch. So next, so these are the table of contents. First, the Ethernet protocol. Okay, so LLC and the MAC sublayers. Okay, so Ethernet, one of the most widely used LAN technologies, operates in the data link layer and the physical layer. Family and networking technologies are defined in the IEEE, okay, 802.2 and 802.3 standards. Okay, supports data bandwidths of 10, 100, 1000, 10,000, 40,000, and 10,000 Mbps or megabits per second, or equivalent to 100 gigabits per second. Ethernet standards, okay, define layer 2 protocols and layer 1 technologies, two separate sublayers and of the data link to operate logical link control, LLC. Okay, so LLC means logical link control, and the MAC sub layers. Okay, so next, so here is the LLC and MAC sub layers application. Okay, so just like, okay, so this is like the layers on our chapter 3. Okay, so the LLC and MAC is on the data link. Okay, here, here. So application presentation session transport network data link, which the LLC and MAC is in it, 802.2 and in the physical 802.3. Okay, Ethernet is defined by data link layer and physical layer protocols. Okay, next, LLC and MAC sublayers. Okay, LLC handles the communication between upper and lower layers. So so just remember that the LLC, okay, handles the upper and lower layers of communication and takes the network protocol data and adds control information to help deliver the packet to the destination. So MAC, okay, constitutes the lower sublayer of the data link layer, implemented by hardware, typically in the computer, NIC or network interface card. Two primary responsibilities: data encapsulation, okay, and media access control. So next, MAC sublayer, data encapsulation, frame delimiting, addressing, error detection. Okay, so, and media access control is in control of frame placement on the on and off the media, and media recovery. So here's there's a figure here. So inside the physical layer, the logical link control sublayer, and the 8 auto.3 media access control, okay, which is divided into many categories here. So the physical signals of layer and the physical medium. Okay, MAC sublayer, data encapsulation, frame assembly before transmission, and frame disassembly upon reception of a frame. Okay, so it is like when you are sending a message, okay, it is the disassembly of the frame is done on that particular frame, and when you are the one receiving it, okay, the frame will assemble again. Okay, so it's called the assembly and the disassemble. Upon reception of frame, MAC layer adds a header and trailer to the network layer PDU, okay, to know where it will be sent. Okay, so write 3 primary functions: frame delimiting, okay, identifies a group of bits that make up a frame, synchronization between the transmitting and receiving nodes, addressing each Ethernet header added in the frame contains the physical address, MAC address, that enables a frame to be delivered to a destination node. Okay, next is error detection. Okay, each Ethernet frame contains a trailer with a cyclic redundancy check, or CRC, of the frame contents. Okay, so MAC sublayer, or it is responsible for the placement of frames on media and the removal of frames of the media. Okay, so there are other meaning. Okay, the MAC carrier sense multiple access, or CSMA process, used to first detect if the media is carrying a signal. If no carrier signal is detected, device transmits its data. If 2 devices transmits at the same time, okay, it is called data collision. Okay. Media access control. Media access control, I mean, okay. So here's a figure here. Okay, so this PC is says that I try to send when I am ready. Okay, so the frame is sent. Okay, so it is ready. Okay, so the frames are sent on the media that's being used. Okay. Methods: contention based access, or characteristics: stations can transmit at any time. Collision exists. Mechanism exists to resolve contention problems: CMCA, CSMA-CD, or for Ethernet networks, and CMCA, CSMA, or CA for 802.11 wireless networks. So as example is the Ethernet for this and the wireless. So next, media access control. Okay, so is the device monitors the media for the presence of a data signal. If a data signal is absent, indicating that the media is free, the device transmits the data. So we have 2 slides here. Okay, so MAC address, frame processing, Ethernet encapsulation. Okay, early versions of Ethernet were slow at 10 megabits per second. Okay, now operate at 10 gigabits per second and faster. Ethernet frame structure adds headers and trailers around the layer 3 PDU to encapsulate the message being sent. Okay, so this is the parts of the frames, which is the preamble, start of the frame, delimiter, destination address, or the source address, the length, the header and data, and the frame check sequence. Okay, so Ethernet 2 is the preamble, destination, oxygen. Okay, so it's the same. Field size in bytes. Okay, so these are the parts. Next, the Ethernet 2 and IEEE 2.3 standards define the minimum frame size as 64 bytes and the minimum as 1518 bytes. Okay. Less than 64 bytes in length is considered a collision, fragment, or round frame. Okay, so this is the Ethernet frame size. This is the parts of a frame. Okay, so 4 bytes for the 802.1 Q VLAN tag. Okay, 2 bytes for tag protocol. 2 bytes tag control information. The figure displays the fields contained in the 802.1 Q VLAN tag. Okay, so this is the Ethernet frame. Okay, so IEEE 82.3. Okay, so there are 7 parts here. As what I have said earlier, okay, the preamble, start of frame, destination, source, length, header and data, frame check sequence. Okay, the preamble is start frame delimiter fields. Okay, used for synchronization between the sending and receiving devices. Okay, the length or type field, okay, defines the exact length of frames data field, describes which protocol is implemented. Okay, so those protocols are tackled in our chapter 3. And lastly, the data and pad fields, so it contains the encapsulated data from a higher level layer and IPv4 packet. So the MAC address and hexadecimal. Okay, so this is the conversion. Okay, so we have tackled this before on our first year. Okay, so our the intro to programming, we have studied on how to convert decimal to binary and binary to hexadecimal. Okay, so decimal is 0 to 15, and binary, okay, so it consists of 0 and 1s, which has 4 bits, and hexadecimal is 0 to 15, okay, which has a alphabet starting from A to F. Okay, so A is equivalent to 10, 11, 12, 13, 14, and 15 for the F. Okay, so next, MAC address representations. Okay, so with dashes, okay, with colons, and with periods. Okay, so unicast MAC address. Okay, here, okay, I need to send this frame to server. Okay, this is the source host. Okay, it will send the message here at the IP 192.168.1.200. Okay, so as you can see here, the MAC address or the IP address of the source is here at the source IP 192.168.1.5, and the destination IP is the 192.168.200 here. Okay, so this is the parts of the frame again. Okay, destination MAC, source MAC. Okay, so this server has destination IP and destination MAC. Okay, it's the source MAC and the source IP. So it's the Ethernet frame parts. Unicast IP and MAC destination addresses are used by the source to forward a packet. Okay, so it is used like a address, or IP addresses, MAC address. Okay, just like the addresses in our house. It is used to locate each PC or server on a network and send a message on it. Okay, so earlier we have a unicast and this is the broadcast. Okay, so the destination IP here is 192.168.1.255. Okay, so it is a broadcast. Broadcast IP and broadcast MAC destination address are used by the source to forward the packet to all hosts on the network. Or this is the source IP. Okay, so the MAC is here and destination MAC. Okay, so all of the data, okay, is sent to all of the servers and PC on the other side of the network. It's a broadcast. And the multicast is okay. This is we have tackled the unicast, broadcast, and multicast on our chapter 4. Okay, so I have remembered. Okay, so the MAC address, okay, this address does not change. Okay, similar to the name of a person. Okay, known as the physical address, because physically assigned to the host or to the host network interface card. Okay, so MAC address is like the name of the person, and the IP address is similar to the address of that person. Okay, so based on where the host is actually located, known as logical address, because assigned logically. Okay, assigned to each host by network administrator. Okay, so here, and then connectivity. Okay, so here. Okay, so here they use satellites, okay, and dishes to connect those routers and to send message from Japan to Paris. Okay, Paris. Okay, a frame from Japan going to the router, wireless. Okay, they have a wireless router here and connected here at the dish. Okay, which is wirelessly connected to the satellite, and the other dish, the router, which is not wireless like this, connected to the PC on Paris. Okay, different protocols may be in use for different media. Okay, so I think this is fiber optic. I think this is a copper wireless. I don't know. Next is the address resolution protocol. Okay, so it's for ARP purpose. Sending node needs a way to find the MAC address of destination for a given Ethernet link. Okay, so let's skip those things. Here the ARP. ARP role in remote communication. If this destination IPv4 host is on the local network, the frame will use the MAC address of this device as a destination MAC address. If the destination IPv4 host is not on the local network, the source uses the ARP process to determine a MAC address for the router interface serving as the gateway. ARP tables are not working devices. Okay. Here's the physical address, internet address, and type. Okay, it's dynamic or static. How ARP can create problems. ARP broadcast can flood the local media. ARP is broadcast overhead in the media and security. Segmentation. Each computer has its own collision domain. Switch at the center of the LAN. Okay, so this is like a backbone, or backbone, I think. Okay, so there are 16 pieces connected in one switch. Segmentation. LAN switches. Layer 2 LAN switch connects end devices to a central intermediate device on most Ethernet networks. So it performs switching and filtering based only on the MAC address. The switch receives a broadcast frame from PC1 to port 1. Here the PC1 to port 1, and then the switch enters the source MAC address and the switch port that received the frame into the address table. So this is the address table. Then because the destination address is a broadcast, the switch floods the frame ports except the port on which it received the frame. Destination device replies to the broadcast with the unicast frame address to PC1. Okay, so the frame from this PC1 is flooded on the PC2 and PC3, and the PC3 replies on the frame with the unicast frame address to the source or the PC1. Next, switch enters the source MAC address of PC2 and the port number of the switch port that received the frame into the address table. The destination address of the frame and its associated port is found in MAC address table. A switch can now forward frames between source and destination devices without flooding because it has entries in the address table that identify the associated ports. This is the duplex settings. So we have a hub here, half duplex, an indirectional data flow, higher potential for collision, hub connectivity. Switch connected to a server by a hub. Full duplex point-to-point only attached dedicated switch port requires full duplex port on both ends. Collision-free collision detect circuit disabled. A store and forward switch receives the enter frame and computes the switch. Computes the CRC. The CRC is valid. The switch looks up the destination address, which determines the outgoing interface. The frame is then forwarded out the correct port. That's the cut through. So password switching, lowest level of latency, immediately forwards a packet after reading the destination address, typically cut-through method of switching. Okay, so the fragment-free switching, switch stores the first 64 bytes of the frame before forwarding. Most network errors and collision occur during the first 64 bytes. Port-based memory. In port-based memory buffering, frames are stored in queues that are linked to a specific incoming and outgoing ports. Okay, shared memory. Shared memory buffering deposits all frames into a common memory buffer which all the ports on the switch share. Power over internet. Fixed versus modular configuration. Fixed switch. Okay, those are switches. Module options for Cisco switch slots. Cisco optical gigabit Ethernet SFP. Okay. Cisco 2 channel. Layer 2 versus layer 3 switching. Okay, so layer 2 is the internet router. This layer 2 switch, and the layer 3 switching is connected into a multi-layer switch. Okay, so this is the multi-layer switch. Combined layer 2 and 3 switch. Next, the Cisco Express forwarding information base, or FIB. Conceptually, it is similar to a routing table. A networking device uses this lookup table to make destination-based switching decisions during Cisco Express forwarding operation. Adjacency tables maintain layer 2 next hop addresses for all FIB entries. Okay, the switch or the SBI or the sorry, or switch virtual interface. Okay, logical interface on a switch are shaded with the virtual local area network, or the VLAN. In a routed port, physical port, and layer 3 switch configured to act as a router port. Configure routed ports by putting the interface into layer 3 mode with the no switch port interface configuration command. Layer 3 Ether channel logical interface on a Cisco device associated with a bundle of routed ports. This is how to configure a routed port on a layer 3 switch. Okay, so I think interface F06, which is the port, and no switch port. Okay, no switch port. I have read that. Okay, masyado malayo. No switch port, and then you add the IP address and the subnet mask here, then no shot, save it and end, and then you show the IP interface brief. Okay. Show IP interface brief. Nice. Okay. So that's it for our chapter 5 summary. Thank you.